check 1, 2, just testing out my mic. I also see there's a question from Joe Herbert, which says, I thought of a good pre-stream question. Does the coding train have good intro ML video that one would suggest? Well, I don't know about good, but I do have a series. I think if you search on YouTube for Beginner's Guide to ML5JS, perhaps this is what Kobe is suggesting right now. Those are my intro series, and I'll be covering the topic from a beginner's perspective today. Hello, happy Friday on the coding train. Welcome all aboard. It's a live stream from me where I'm going to do a whole lot of coding stuff. I don't know when I was last here live streaming this way. It feels like I've been gone for a very long time, down deep. I've dug myself into a hole. I'm covered in piles and piles of old computer mice that I purchased off eBay. I've been participating in something called the Computer Mouse Conference, which just started yesterday, but I was invited to give a talk, if you will, if I could use that term, at the conference. And all of the talks were, this is a fully online conference, and the talks were are all being pre-recorded. There's some, I think, live panels tonight. So I chose not to make it easy on myself and simply record kind of a more typical kind of presentation, and wanted to try producing a kind of a video that was a bit different than the kind of content that I usually make on the coding train. Thank you for listening to me about this right now. And it was really hard. And I had a lot of help from a lot of people. I have so many people to thank. And if you have no idea what I'm talking about, I apologize. I'm going to explain more about what the Computer Mouse Conference is in one moment. But what I am excited to let you know right now, the sun just came out here in Brooklyn, New York. It was just pouring rain like half an hour ago. That's not what I was going to tell you. What I am excited to tell you about is that I will be publishing the video from the conference, which played last night, probably around on Monday on the coding train. So today I want to talk about and go through some of the code examples. It's a little bit backwards because I'm assuming that many of you who will be watching this live stream haven't actually seen the video. So I'm giving you a sneak peek, a preview into some of the demos there. I also kind of never really finished the last demo that's in the video. There's a little bit of smoke and mirrors. So I really would like to work on that. I would very much like to see if I can train a recurrent neural network in Node with TensorFlow.js based on mouse movement data. And yeah, I doubt that's going to happen in the next hour and 45 minutes, but I will get it started. Let's see. So where do I want to begin? So let me bring over my screen here. So first of all, up here in the top left, currently all of my mouse movements are being tracked by a processing sketch that I will explain in a moment, and they are being recorded into this sketch. And after, I think, 40 minutes, that image will be live tweeted at the Twitter account the mouse sees. So let's see. This was the last one 2 hours ago from me that was tweeted here. So I don't know how long it's been. I should put something in the sketch that says how long it's been going. But at some moment of time, that sketch will if everything's working correctly, that sketch will become blank, and then that image from that sketch. Do you hear the helicopter flying overhead? I'm in the attic of. And so that helicopter was flying kind of close of my place here in Brooklyn. But so let's see if that happens. Let me first get something out of the way, which is I'm very excited to thank today's. I have my console of buttons. There it is. Very excited to thank today's sponsor of the coding train. Brilliant. You can sign up for free right now, this very moment. You can turn this whole live stream off and sign up for free. You can keep it on and sign up for free at brilliant.org/coding train. I'm very excited about what I want to show you about halfway through the stream today on Brilliant's website. They have a course about learning all about artificial intelligence and neural networks. That's the topic of my live stream. So I'm going to look at neural networks in TensorFlow.js. And of course, there's this ML5 project, which I will allude to, but some of the things I want to explore are not yet in ML5. And so if I can explore them in TensorFlow.js, then they could maybe get added to ML5 later, which would be very exciting. If as a really wonderful way to learn along with the kind of stuff that I do is Brilliant, which has a whole set of interactive lessons where you can try out ideas and answer questions and join a community of people helping each other in topics in math and science and physics and computer science. There's a Python program, of course, so many things. So you can sign up for free at brilliant.org/coding train. And if you are interested in signing up for the premium service, which unlocks all of the courses, you can get 20% off for the first 200 people by going to that link. All right, let's see right now. Yes! I thought the timing might work out. I felt like I started it around 40 minutes before I went to live stream. So let's see. Let's see where. Oh, I lost the Twitter account already. Did it work? No! Where is it? Oh, is there an error? Oh, I'm so sad. It went blank and I don't see it. Oh, I tested it and everything. Oh, I got a bad. What's this? Too large. Oh, look at that. Request entity too large. So I never bothered to do. Why is it too large? Because it's a PNG. What if I save it as a JPEG? Oh no, but I'm doing it as a base 64. Okay, I think maybe it's just my node code. How do you feel about me debugging to fix this right now? I'll do it after I finish streaming. Let's change it to, let's make it a shorter amount of time. Let's just do 10 minutes and it'll be so much less activity. I think that base 60, shouldn't it be the same? Like, shouldn't the base 64 encoding of this image, oh, my resolution changed. Could it be the resolution of the image? Let's print out, like, what would make it that suddenly this file was too large to post to my server? Let me print out the display width and height. 1920 by 1080. I feel like I was doing that before. I mean, I could certainly... Oh no, this is so sad. I know I can fix this for sure after the stream is over, but I wanted it to be posting while I'm streaming. Let's just try 5 minutes and see if it has to do with the actual like amount of activity in the image. I could also just go into server. I set like a data limit, I think, on the node server that's receiving the image. Because, I don't know, that seemed like the sensible thing to do. Maybe I need to set it higher. Let me just put it on... Let's put it on 5 minutes. We're going to get 5 minutes of mouse movements. And see what happens in 5 minutes. Okay. Oh, I'm excited that you're all here with me for this. So where was I? All right, we're going to come back to the Twitter. Okay, so the Computer Mouse Conference. This is the URL. Complicating I don't know if you can hear the screaming that's coming from downstairs. So Friday afternoon is not a good time for me to live stream. The children are home from school, lots of activity going on, but I'm going to power through this. Complicatingthecomputermouse.net. So if you go to this website, you can buy a ticket for the conference still. Later at 6 p.m. Eastern tonight, the live zine, the streaming of artist Neto Bomani is making has a camera view of her workspace, tabletop workspace, and is making a live paper zine and printing and cutting while the conference is going on. You can hear the audio from the conference in that zine stream just for free. And we could go look at the schedule. Let's see what's on the schedule for tonight. We can see all these wonderful things that are happening. So I encourage you to check out and maybe join the Computer Mouse Conference if you're interested. Isn't it wonderful that there is an actual, I don't know if it's right to say, but almost academic, intellectual conference all about the computer mouse? Nothing about me is academic or intellectual, but there was a lot of brilliance on display last night from all of these amazing presenters. And I'm assuming that all of these talks will eventually be available. I'm enjoying Charlie's comment in the chat. Children home from school, helicopters home from school, lots of distractions. It is true. So, I could go on and on about how much I love I love the Computer Mouse Conference in 2020, how much I love it so far this year, and how much I'm looking forward to it tonight. But let me get to why probably you are here watching this stream. This is the page. You can actually just go to thecodingtrain.com/mouse learning. So if you go to that URL, it will take you to the page. And thank you so much to Dusk Verkus, who's in the chat, I think, who has been instrumental in helping me get all of this material organized to be online. So everything that I reference in the talk, all of the artists are here listed with links. And all the various articles and publications, you can find them here. I wouldn't be surprised if I missed something. So if something is missing, please tweet at me at Schiffman. You can open probably an issue also on the Coding Train website GitHub repo. So you could also potentially go here to the Coding Train website issue and click new issue if something is missing. Of course, how do you know if something's missing if you haven't even seen the talk? It'll all work out eventually. But there are a whole set of examples here. So I'm trying to think about how I want to approach this. Oh my goodness. I must someday finish the live poll project so I could just throw up a live poll while I'm streaming. Got to make that happen. So let's start with collect and visualize mouse data, because in order for me to work on, the thing that I want to work on is predicting mouse movement. So actually let's go ahead and a little treat for you. I am going to play not the full talk, but just like a portion of it at the end for the section that I want to discuss here. So let me scan through it. You can sort of see the video, parts of it here. And let me get to what's the part that I want to get to. Okay, let's try this. You do not hear the audio. Let's see, I will fix that. So I use this software called Loopback. If I turn this on, this will take the audio and send it out to USB capture. So that should fix that. Let's see if we can get this going here. To collect and save all of my mouse pointer positions into a CSV file. CSV stands for comma separated values. It's a very standard data format that you can easily reload into all sorts of other things like a spreadsheet. You can then take this data and visualize it in a myriad of ways. Oh, I wasn't going to show this animations, part. It's fine. Heat maps. I tried a few different ones. With all of these mouse movements saved, I could also use them as training data. I can analyze the probability of any moment of the mouse going up, down, left, right, and replay a sequence based on those probabilities with something known as a Markov chain. I could feed this data into something called a recurrent neural network, a kind of neural network that's very well suited for sequential data, time series, text, music.
vector paths. There's a well-known machine learning model called sketch-RNN.
Come on, the next part is what I'm trying to get to here, folks.
Data set to generate doodles of all sorts of different types of things, and I can take the results of that recurrent neural network, trained off of my mouse movements, to take a nap and let it just take over and control my computer. Now, I didn't include mouse clicks in here, although I could have. This way, I just, I'm safe and I'm not going to end up, who knows what nefarious business, the sort of dream version of my.
So I don't know what you can see, here, but this, what's going on here is this processing sketch is actually listening to a node server, which is spitting out mouse locations where it wants to move the mouse. So these are normalized between 0 and 1. So if my pixel dimensions are 1920 in width, then 0.37. I don't know, you do the math. It's a little less than half of 1920. What's half of? Oh, I help my children with their math homework all the time, and I feel like I've been like learning all these new strategies to do things in my head, and I'm like, as soon as I'm live streaming and trying to do math in my head, it's the most terrifying thing in my entire life. So the idea here is that this particular, so I want to try to rebuild this project again a little bit right now. It didn't really work very well. So it worked enough for me to kind of demonstrate in the video. This is actually a little bit of showing okay, this was my mouse prediction. So first thing I need to do is collect a lot of data of me moving the actual mouse. So let's get to do that. And by the way, I think here, yes, it worked. So this was my latest 5 minutes of mouse movements from the Coding Train live stream. So I don't know why the many more, the larger image, the image with more stuff in it doesn't make any sense to me. If it's a base 64 encoded image, is the base 64 encoding compressing it somehow? Because wouldn't it just be the same number of bytes no matter what the colors actually are? I'm very confused. Thank you. Thank you to Abjit, who gave me the answer to 1920 divided by 2, which is, I would do 1800 divided by 2 is 900. And then I could do 120 divided by 2 is 60. And I got 960. Boom. Just like that. Boom. So what am I doing here? Let's close. Let's go back. I think tweeting this every 5 minutes is going to be too much. So let's switch it back to 20 minutes. And we'll let this go in the corner here. Okay. Jabril's is here, and I have to unhide. No, I held it for review. No, I hit delete by accident. Jabril's is here, and I hit delete by accident. You can post your message again. Why was it held? I didn't mean to. My favorite, internet person is Jabril's. I mean, I probably say that about a lot of people when they pop in the chat. They're all equally tied. All of my favorite internet people are equally tied as my favorite internet people, Jabril's being one of them for sure. And there's a limited number, so it's not like there's thousands of them. Okay, moving on. What am I doing? Okay, I've got to collect the data first. So so what am I doing here? Mouse learning. So we're going to the collect and visualize mouse data repository. So I'm going to be writing a lot of the code today, but I need to make use of some code that I've already written because no way am I doing this whole project from scratch here. All right, so let's clone this repo and put it on my desktop. And let's open it up. I can't believe I deleted Jabril's message by accident. I was trying to click let it post. All right, so now here is, all right, so there's a bunch of different processing sketches here. By the way, also thank you to Dusk. What I've recently learned, and maybe I should pursue this, is you can actually use node.js to also track your mouse movements. So you need some programming language or environment, some framework that has operating system level access, right? I'm not talking about using mouse X and mouse Y the way that I might talk about in P5 or in processing to get my mouse movements over a canvas. I want all of my mouse movements no matter what it is that I'm doing. So you can see here, like this down here, this is size to be smaller. Words are failing me more and more every day. This is what happens when you get older, I think. It's happening pretty quickly for me. But over here, so if I just take the mouse and like hover it down there in the corner, it's down here in the corner, we should start seeing it appear up there. Oh boy. So now, how do I do this? I'm going to go to this mouse data collect sketch. So the way that what I'm actually making use of is something called the robot. And by that, I don't mean the robot. I do kind of, but I don't have a sound drop to like robot dance to. Probably could come up with one, but you want me to move on, I can tell. All right, so let's look at what I'm talking about. Java robot. I love that it's called the robot. It doesn't matter whether I'm looking, this is an older version of Java, but you can do all sorts of things. Like I can use the Java robot class to get a screen capture, to get a pixel color, key presses. So, but what the robot class is meant to do, it allows you to automate things that you might want to do on your computer. So I could actually write a Java program that's just typing keys automatically, moving the mouse. So if I wanted to automate some process of opening files and changing something, if I could kind of figure out what the logic behind it is, or record myself doing it, then replay it, there's a lot of possibilities there. Now, I think I scared Jabriels away. I just want to see a message from Jabriels again in the chat. That's when he tweeted him or something. He left. He saw that I deleted his message and thought I never wanted him to come back. But I love you, Jabriels. You're one of my top 25 internet favorite people. Wait, what? Way at the top of that top 25. All tied, as I said earlier. I just don't want to leave anybody out. Okay. I was saying something here. So, and actually now that I'm realizing it, the robot class is what I want to use once I want to control the mouse. I actually don't need to use it at all for what I'm about to demonstrate to you, which is that, I want mouse info. So let's look for mouse info. So there's a difference between tracking the mouse, right? What does it mean to listen to all the mouse positions and record them versus control the mouse through code rather than through the actual user interactions? Mouse info Java. So if I go here to mouse info and I can get pointer info and I can get the number of buttons and where the pointer is and all that sort of stuff. But I've done this, I've written the code. So let's just take a look at it. I'm a little bit afraid to run this. I don't remember what I'm doing here. Why do I have the robot one in this? Unnecessary. Let's take out robot completely because I don't actually need it. Let's call that start tracking. And I don't know, it sort of seems silly to have a whole extra function for that. Let's just move that into setup. Okay. So the first thing that I'm doing is just to make sure there is a mouse attached, I think I can get the number of buttons. So I guess it could tell me like how many buttons does this mouse have. I have no idea. I'm just using the trackpad right now. I don't have another mouse hooked up, but let's see what it says. So there's 5 buttons? How are there 5 buttons? What are the 5 buttons? I have no idea what that is. And why am I getting this null pointer exception? Who knows? All right, so, but I know that there's a mouse. If there was no mouse, I would exit the program. Now, in draw, let's look at the crucial sort of element here is, and I see I have some code commented out that I'm not using, is this track mouse function. So what the track mouse function does is it first asks for some pointer info, right? Now remember, I could just say print line mouse X, mouse Y, but mouse X, mouse Y would only give me the mouse locations within this tiny little canvas. And I want the mouse locations no matter where I'm moving. So I can say get pointer info. Dusk, I see that you're in the chat. If you could link to me the name of that node package you showed me, I probably want to bring that up at some point too. So get pointer info. Now I have this pointer info object. I could say get location, and then I could say get X and get Y. So this could probably all be written in one line of code. The other thing that I'm doing is that I have my own mouse point class. Basically, I created a little class just to wrap the X, Y, and the time. I haven't done anything with the time, but I could imagine if what I'm doing is collecting a large data set about my mouse movements, that I might want to record when they occurred as well. And then I'm keeping track of the previous mouse position. That feels useful for visualizing if I want to connect them with a line. I also am doing something. I don't know if this is I'm just trying to keep my data set a little bit smaller and more manageable. So I wrote this function called sane that basically says, hey, if the mouse hasn't moved, don't bother recording it into the history. So this array list is a history of all of the mouse points. To summarize, I've got a processing sketch. Where's my post-production animation that's just gonna put the bullet points up here? It doesn't happen when I'm live streaming, but I could type out this pseudocode. Let's open up text edit here. So let me type out the pseudocode for this so you can kind of follow. So every time through draw, get X, Y of mouse. This add X, Y, and time to array list. And I think if a new XY, then add that. So if it's a new XY, if it's moved, then add that to this array list over and over again. Also draw scale down. Well, I thought this was going to be really useful for me to summarize the code. It's quite simple. Then also after X number of mouse locations, save to CSV file. So this is really it. So every time through draw, ask for the XY position of the mouse. If it's a new one, save it along with the time. Then keep all that into a big array. But if I just stop the program from running, that array will be lost. So take that array and save it to a CSV file. What's a CSV file? Let's take a look at that. So I believe right now the code says if the array list has 100,000 data points in it, save it to a file. I could be sending those to an API somewhere to save the data in the cloud, or I could be storing it in a proper database or saving it continuously. But this is my sort of hack. Let's just save, if it's 30 frames per second, 10 seconds would be about 300 points. So let's just save about 300 points right now, just so we see that this works. And let's also say, there must be a print line somewhere in save data. I'll just put print line saving data. I'll talk about what's happening in this. So I'm moving the mouse around. It's this console. I got to make the console bigger, right? Can I do that in console font size, also 32? So you can see that better. Let's see. So we should be able to count to 10, 1, 1,000, 2, 1,000, 3, 1,000, 4, 1,000, 5, 1,000, 6, 1,000. Come on. It's got to have been 10 seconds already, even though I only counted to 5. Saving data. All right, great. Save data. By the way, I could just implement, I think I might have actually implemented this. I forgot. I don't see it. Yeah, I forgot that. Of course, here I am. I implemented. If I click the mouse, it'll save the data automatically. So that was silly. I could have done that. Let's now take a look. So in the data folder, we see there is now this CSV file. And what's in this CSV file? It is a table of XY, XY time, XY time, XY time. So this is me. And so that's what's being saved. So I think in order for me to attempt to see if I can get an AI to start controlling my mouse for me based on my own mouse movements, and I'm using the term AI just to be just to sort of like get myself through the sentence faster. It would make sense to unpack what I really mean by that, because ultimately we're talking about a machine learning algorithm and a neural network based machine learning algorithm. What kind of neural network? So that's what I want to unpack here. But I think maybe as to try to get a test going, maybe I'll just move the mouse in a circular pattern, because maybe that's something, if I could get it to learn that and reproduce that, then I would know that my methodology is sound. So let's do the following. I'm actually not going to bother to save the data automatically. I will just save upon a mouse press. So okay, hold on. So now remember, let me do some circle patterns in a clockwise direction. Ooh, it's kind of hard to do this. Oh, I don't hear the music anymore. Oh, I do. This is good circle pattern music. I wonder if I'm moving it too fast. You know what? Let's try this again. I'm gonna move it slower. Oh no, I keep wanting to do it over the canvas, and I keep forgetting that that's besides the point. This is going to show up in the tweet as well. Ah, Jabril's is still here. Everybody do the mouse in circles dance. I think this is enough data for me, yeah? And now, for the moment you've all been waiting for, I'm going to click the mouse and save my data. That was a little anticlimactic, but I did it. Okay. All right, so let's take a look. It's a very small file, but that's good. So let me just take a look at this. This is my mouse. Does this look to you like I'm moving it in a circle? I think it kind of looks like it's going in a circle. Look to the right, to the right, to the left, down, 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 up, 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 up. Yeah, looks pretty good. Looks pretty circular. Okay, now, this is great. This is moving along so quickly here through this project. Let's now switch. I'm going to close process. Not going to close processing completely. I'm just going to close this data collection sketch. I'm going to leave this mouse tweeter bot thing running, which in case you just recently joined, every 20 minutes, this is recording all my mouse movements. And look at it. I love this sort of like, how you're really seeing that circular pattern now emerge in there. But I don't want to stop that. Let me just minimize it. Okay. This was my attempt to be good at explaining something, which didn't really work out. And now, so what I'm going to start recreating is this particular repo that's predict mouse movement. But I'm going to write this code. I mean, nothing is truly from scratch, but I'm going to start this project over just because it didn't really work out. But I might have to refer to it because I don't know TensorFlow.js super well off the top of my head. Okay. Great, and we have a machine learning researcher for wireless security in the chat. Please help! I don't really know machine learning. I just played somebody who does on TV. I also have this really like big question in my head, which is this video is so unlike most of my content. It also is specifically for this conference. So I wonder if it needs like a short intro. I should record a quick intro to it, but yeah, I don't know. Think about it later. All right. So let me get to here. So let's make a directory. We're going to call this mouse AI for Jabril. Mouse AI. I'm going to say npm init. That's what you do these days, right? I don't know. I should say like yarn or something, or there's something newer than yarn. I think I kind of forgot. I think I forgot to eat lunch today. Like I'm very hungry all of a sudden. I'm feeling kind of tired. I had a very large late breakfast. Today it's been an unusual day for me. A very, very nice day. Beautiful, beautiful day. And I was outside for quite a bit, and you don't need to hear all about my day. I could talk about it. It's not that interesting. By the way, I'm fostering a puppy who hasn't arrived yet. The puppy's arriving tomorrow. So you all hopefully know my dog, Gloria Pickle, who makes many appearances in the mouse conference video. But tomorrow, Gloria's going to get a friend, Marlin. And, I'm getting breaking news from Simon here. Do npm init-y so that it automatically does it automatically. You don't have to manually make it do it automatically. Oh, well, I already did it, though. Sorry. All right, moving along. So stay tuned for cute puppy photos tomorrow. So what am I doing? All right, so now let's open up this directory. And let's create a file called index.js. So the first thing that I want to do is just parse that data file. So I've got to find that CSV, which is presumably on the desktop in computer mouse data collect. Which one was it? The later one, this one. Let's make a copy of that and just put it here. So let's start with, and I apologize to any of you who are new to coding. I really, really strive to have everything be accessible and approachable, no matter your skill level watching my stream. But admittedly, anytime I'm diving into writing some node code and trying to use something like tensorflow.js, there's going to be a lot of confusing stuff. Just know it's confusing to me also. But a node is an environment where I can write JavaScript code and execute it through the command line, basically. Run little JavaScript programs on my computer. I'm not doing anything with a web browser right now. And one of the things I can do is I can import various node packages. And one of them that I want to import is called FS, or file system. And then I think I can just say like data is a read file, and I'm going to use this read file sync, so I don't have to worry about a callback. And then I need to say what file I'm opening, like mouse.csv. And then probably like, what's it's encoding? It's a text file or UTF-8. So let's just see. And then if I say console log data, and of course the file isn't actually called mouse.csv. So let's get the full name. I could just rename it, but all right. So now, can you see all this code? Let me move this over here. There we go. Now I should be able to say node index. So now I'm going to execute that program. And look, there's all that CSV file. So I'm sure there are countless node packages that help with CSV parsing. But to me, it's actually kind of easier to just do this manually. It's such a simple file. So I think the first thing I want to do is say data.split by a line break. So I will now have an array of lines. Then I can go through every single line. And I'll say the row is lines index I dot split based off of a comma. And then the X is the row's first element, and the Y is the row's second element. So if I say console log X comma Y, we should have this parsed. Great. So now I'm seeing all of those X, Ys. That's good. Now here's the thing. I probably should. Basically what I'm attempting to do is recreate sketch RNN. What's sketch RNN, you asked? I can hear you asking it. All of you asked it simultaneously, just as I said it. I can hear you. sketch RNN. Let's see here. This is what I'm looking for. So I do have a video all about how to use sketch RNN. Sketch RNN is a machine learning model that was trained off of a large data set of doodles. For example, doodles of cats. My children have written a song about cats, and I'm using everything, all of my strength right now, willpower, to not start singing that song. But let's see. I think there's like a demo in here.
Hello.
If I just like skip to the end, you can see here. This is what sketch RNN does.
Oh, it's not working still. Oh, this. So this.
Go a little further.
Off where we left off, and I will say goodbye to you by letting you watch a compilation of sketch RNN drawn cat.
Yeah. Move it along. So you draw, and then the AI takes over and continues the drawing. So I'm basically trying to recreate this, but with my own data. And I do happen to know that sketch RNN, I believe, doesn't use the raw position data of all the points. It uses the difference between the next position and the previous position. So you can think of it as like vector paths. But to keep things simple right now, let me use the raw data. One person in the chat is asking me to sing it. All right, but I'm gonna start small and not do that. So the next thing I need to do is I want to normalize this data. Let's put this in. Let's make this a two. And so machine learning systems, neural network based systems, generally. Someone's at front door. Generally are looking for data in arrays. So I already have it in an array, but let me make my own array. I probably should make it an array of arrays. XY, 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 XY. Let's do that. So I am going to say, I'm going to make an array, like I'm going to call it raw input. So I want to create the raw input to the machine learning model. And the raw input equals raw input equals push. I want to push an array with just the XY, and then I need to normalize that data. And I happen to know that my resolution, obviously I wouldn't want to really hard code this, but if I divide it by 1920 and by 1080, I've normalized all the data between 0 and 1. Now if I say console.log raw input, there we go. So this is now the data that I want to send into the neural network that I'm going to develop is going to be in chunks. Chunks of XY positions, all normalized between 0 and 1. Looking good. All right, so next up. All right, I really need something. I should have set up a notepad for me to diagram today, so I'm just gonna have to use my words. Please bear with me. What I'm looking to do ultimately is what's known as a regression. A regression meaning what I want the output. What's the output of the neural network? I want one XY, right? The input is maybe, hey, here's my previous 10 XY positions. What's the next one? If you were moving in this direction all these 10 times, where would you go next? So if I'm doing this, and so it's a regression, but what kind of architecture do I want? Well, you can think of this as a time series data. It's a sequence. The sequence might go on forever. And the architecture for that kind of data, music, text, time series, financial data, you could probably think of other examples, would be something called a recurrent neural network. And there's more recent research and variations on that, and LSTM and GPT, transformer stuff, all that stuff. Yeah. Our machine learning researcher in the chat will explain all of that to you. Thank you. Machine learning researcher in the chat who is slowly approaching onto my list of some arbitrary number of favorite internet people. We'll see though. The word is still out. But I want to know that I can get this to work first. So let me try doing a sort of more classic fixed input neural network. So instead of it being sequential, I'm going to train a neural network to make a prediction based on some fixed number of previous mouse positions. So if I always know, like a sequence could have 5 numbers in it or 1,000 numbers in it, and it's continuous. But it's not, I'm not going to have a robust system with a lot of memory, but maybe I could get something to work if I always just say the input to the neural network is 10 mouse positions and the output is the next one. So that's what I'm going to do. So I need to start architecting my neural network. Now, ordinarily, I would go instantly to ML5, and I could. I wish I could. I wish I was, because I know how to do it very well with ML5. But ML5 doesn't run in Node, and I don't feel like opening up a web browser and figure out that. And I would like to learn a bit more about using TensorFlow.js directly in Node, because someday I would love for ML5 also to work in Node. So that's where I'm going to go. Oof. I just had to say all these words over and over again to build up a little confidence that I can make this happen. So let's go to... you can see what I was Googling, by the way. It came out right before I started live streaming. TensorFlow.js RNN cell. Because if all goes according to plan, which it won't, I will get to investigate this before this stream is over. I doubt that's going to happen. But I'm going to not worry about that just yet. So let's go to the API documentation. And one of the things that's hardest about working with TensorFlow is this idea of understanding what it means to work with tensors. This is why I like to use ML5, because ML5 obscures the need to work with sort of lower level memory management and tensors with your data. You could just give it an array or give it a string and it'll sort of figure out how to do that. But I'm now opening up this can of worms, which is TensorFlow.js, and I'm going to have to do it myself. By golly, and I can. What's the Stuart Smalley daily affirmation? People like me, gosh darn it. They really do. I'm good enough. I'm smart enough. I don't know. I stopped watching Saturday Night Live after the 1980s, so that's about where my knowledge leaves me. All right. So I don't know where to begin. Well, where to begin actually is I need to look at the getting started page. There's got to be a getting started page, right? Because I want to use it in Node. tf.js node. There we go. This is what I want. So I need this node package to use it in Node. So let's do this. npm install TensorFlow.js node. Boy, if this doesn't work, it's not going to be a very long live stream. Let's install this. So npm install, you might be wondering like, hey, you used fs. How come you didn't have to write npm install fs? So in Node, some packages just come with Node, but TensorFlow.js for Node is an additional package I have to add. Okay. Oh, it's got to build TensorFlow. Ooh, this is exciting. Oh, I was about to like put on some, ooh, did it work? Thank you. Are these, I thought it would take longer. I think it worked. Okay. So now I think I just need to say require or something. Require, here we go. Let's do this. I'm not going to attempt, so you can get it to use your graphics, your GPU hardware. That's not something that is within my powers today, and I definitely don't need it. I'm making a very small little neural network here, just a little bit of data. So let's do that. So now the first step is for me to turn this data, this raw input data, and can I say console log table? I noticed that question in the chat. Yeah, console log table works in Node, which makes a nice little like sort of spreadsheet version of what I wanted to print out. I need to turn this into a tensor. So how do I do that? So by the way, tensor, it sounds like, oh, tensor, that must be some like really complex concept that has nothing to do with anything I've ever done before. How will I ever understand? Why is it called TensorFlow? What's a tensor? So tensor is really just another word for a bunch of numbers. And maybe that's, you can argue with me in the chat whether that's accurate to say, but tensor, the reason you might think of an array, like, well, is tensor and array the same? No. So an array is a list of, could be in a list of numbers, but by definition, an array is one dimensional. So a tensor is kind of a nice word for any arbitrary multi-dimensional array. Am I getting this right? I have a whole video where I explain this and I kind of have forgotten it. But really, it's just another word for like an array you might think of as one dimensional. A matrix is two dimensional. Tensor is a generic, any dimensional bunch of data. I'll look at the chat to see whether I've been corrected or not. All right, so now this data is so something that comes up in machine learning a lot is the shape of your data. And what's lovely about using console.table is I see the shape. The shape is, 1,435. I mean, that's probably the index. I'm sure it started from 0. So it's 1,436 by 2. There's 2 columns. Now, it looks like it's by 3, but these are just the index values. So that doesn't really count. So this is 2-dimensional data. So if I go back to the TensorFlow API, I want to make a 2-dimensional tensor. So with values and shape. So I should be able to say now, const input tensor, I'll just kind of call this input, equals tf tensor 2d, my raw input, my shape is raw. Well, let's look for raw input.length. And I'll call that rows. And then I know it's 2 columns. I don't know if this is going to work. And then I can say input.print. So in TensorFlow.js, instead of console logging it, you call print and it'll put out a preview. Let's see if that works. Oh, good. Hi, where's my bell? My sound effects for being happy. I can't believe that worked. I must remembering things from TensorFlow. Okay, great. So now I have my input data. I have my input data in a tensor. Next thing I need to do is I need to design my neural network. So my neural network needs to have inputs that correspond to this input data, and it needs to have outputs. I know there's 2 outputs. So what goes in between? Don't worry, I will get there. Oh, the last line is empty. So that's very good. That can really mess things up. Thank you for everyone in the chat mentioned that to me. The bell, it's like funny not having the bell. Like I feel like I use it whenever there's like really salient, important moment. And I'm getting to the halfway point of this live stream, so I will be taking a break, having a snack. Great. So this is important that I do this. And let's just, because this is really gonna mess stuff up. This not a number here. Thank you for noticing that. So, and I don't want to console log. I just want to see the tensor. I don't need to console log this anymore. So let's do this again. Great. All right, so we can see I have my input data. So now, back to the TensorFlow API. So what I'm looking for next is to create a model. And I want to make a sequential model. A sequential model is a model where the data flows in one direction in a sequence. There are inputs and there are outputs. The world of machine learning and neural networks, there's all sorts of different kinds of model architectures. I'm starting with the most basic, simple one. Okay, so a sequential model. So I'm going to start off doing this. I'm going to create my sequential model. Then I need to configure the first layer. It's going to be a 2-layer network. There's just the hidden layer that receives the inputs and the output layer that takes the output of the hidden layer and squishes it into my XY prediction. So looking at this, let's do this. So the first layer is now okay. So this is the input shape. Right. My data actually isn't formatted properly. I want to have so here's what my data is now. This is what my data looks like. But remember, what I'm using as my training data is groups of 10. Like, what is the next mouse position based off the previous 10 mouse positions? So there actually should be another array in here. And this should be 10 of these. And then another one. So the data should actually look like this. It should be in groups of 10. And these would each be 10. So how do I do that? So I want to, let's make a variable. What's a good name for this variable? People are telling me the font size is a little small. Thank you. Let me try making that a little bit bigger. Let's see if this helps. Better? Hopefully this is better. Okay, so I need a variable for history size. Chunks. I'm going to call it chunks. I want chunks of 10. So for let j equals 0, j is less than the number of chunks, j plus plus. So now, and then for each chunk, I want to have a chunk, which is an array. Boy, did I make this complicated. And the chunk should receive, oh my goodness, this is super interesting. This should be I plus j. And I can't go all the way to the end of the array, because if I'm always taking blocks of 10, I have to stop at the 10th to last position. I have some syntax errors somewhere because it's not auto-formatting nicely. Let me move this over since I'm sitting here. Oh, but I don't see my beautiful mouse visualization. That's fine. Okay, so go through all of the lines. For every line, get a group of 10, push that into this chunk, and then raw input push that chunk. There's a syntax error or something. Does anybody see it? Huh. Well, let me just try running it. $34. You're probably all telling me in the chat. Oh, because I have all this nonsense down here. Well, I forgot about that. Okay. That was just reference material. Okay, I think we're good now. Oh, but it's not a 2D tensor anymore. Hold on. TF tensor, the number of rows, the number of chunks, then 2. Is this my shape now? Is that how you do it? I'm kind of afraid. Let's come at this. All right, let's see. All right, this looks good. I'm on a roll today. That looks right. Groups of 10. Groups of 10. Amazing. This is so amazing. No, so people are saying, I should be saying plus equal chunks. I don't actually want to do that. My training data takes 0 through 9, predict the 10th. 1 through 10, then predict the 11th. 2 through 11, so that data is repeated with each chunk. Now again, this is not the proper way of doing it, but this is how I want to do it. I absolutely do not want to move up by the chunks. I'm looking for as much data as possible, and I'm taking 10 chunks at a time, sliding across the data. Okay, so now the input shape is still the the input, I think I would just say it's the number of chunks, comma 2. I think that's the input shape, right? It's 10 things of 2. Okay. Now the number of units, I'm going to leave this as 32. It's sort of like, and by the way, there's like, I feel like it should be wrapping some of these. All right, I'm not going to worry about that. I never can get my code formatting right. If I do this, well, yeah, let me do this because I think this is a little easier to see now. Okay. So I'm going to leave 32 as arbitrary. Now, the next thing that I want to add is the output layer, which has 2 units. That's it. Now I want this to be on one line. Although I think I need to add like activation functions and things like that. Let's do it this way to be consistent. Okay. All right, so I'm creating a layer that receives the inputs. 32 is, I'll get to why it says units 32. We'll decide that later. And then there's 2 output units. Yeah, I probably also could flatten the data, but I'm, yeah. Hide the side tab. I don't know what that means. I need to take a break in a minute. So just give me a second here. But I kind of want to I want to at least, actually, this is the perfect time for me to take a break. I've never aligned my sort of sponsorship so perfectly with my content, but it's so I'm streaming till 5 today, which is about another hour. I think I'm going to be able to get through quite a bit more of this, but let me take a short break. I'm not actually taking a break this second. Don't go anywhere. I'm going to tell you about today's sponsor, which is Brilliant. So I don't know about you, but me, I love to solve puzzles. And I love to learn new algorithms and try to figure them out. And then when I love to get things wrong because that's the best way that I learn. And so for me, one of the a really wonderful service and website, and they have an app that I use, is called Brilliant. So Brilliant is a website. It has courses and lessons and a community of people, all lifelong learners. Stuff for all ranges of ages. One of the things that I like to say, look, it's actually telling me continue learning. Look at this. It somehow knows. The Brilliant has some really good AI that knows that I need to continue learning Introduction to Neural Networks. Well, I was working on it earlier as a review to understand about neural networks. But I think the thing that I would just show you here is if I just go to courses, I don't think it says that I could say much more about how well suited this is if you like the coding train, that you would like Brilliant, because look at all of these topics. Computer science fundamentals, neural networks, math fundamentals, applied computer science, browse all 60 courses, number theory. This is one of my favorite ones right here, infinity. So if you like some of my videos on fractals, I mean, so many of my coding challenge ideas came out of Brilliant. So just to give you a quick preview of some of these, I have a couple of videos that I can play. So there's a Python coding course that you can actually, so I don't do videos on Python, but if you want to learn Python, you can go through these interactive lessons, see how they work. The one that I'm working through now, which, I was saying like, oh, I really need visual diagrams to explain some of these concepts. They're really beautifully illustrated in the neural networks course. There's lots of material that you can available just by going and signing up for free I have this, brilliant.org/coding train. If you go through that link, it lets them know that you found Brilliant through me, which is just a nice thing to do if you can. No big deal either way, but I definitely would appreciate it. And then if it seems like something you would really like to unlock all of the premium courses and content, you'll also get a discount through going through that link, the coding train. One of the things that I like to say, I don't know, it's not exactly gift giving season right now, but you've got someone's birthday coming up, buy a nice gift. Is getting somebody a premium subscription to Brilliant. It's something that I do buy as gifts for other people myself. All right, so let's see if I can just briefly, before I take my break, dive into the neural networks course a little bit. Let me move this out of the way. So let's go to Introduction to Neural Networks. I'm going to click Continue Course. And I want to skip to, I would definitely recommend going through all of the course, but I just want to skip to the neural network one because it illustrates a lot of the concepts, and here it is, of what I'm talking about. So the idea here is like, this is the input data. Now it's different. The input to this neural network is an image, but you can see it has a shape to it. Like the shape to this data is 1, 2, 3, 4, 5, 6. It's probably 27, if I'm guessing. I don't know. I can't count. Somebody could count this for me. But the shape is the number of columns by the number of rows. So similar idea. And then all of these go into, like if I would go back to my code here, 32 units. Well, that's the number of these hidden nodes. Now there aren't 32 here, and then there's actually 2 hidden layers. So in this, if I were to try to recreate this architecture, I would have to add 2 layers. And then there's an output one. You can see the output has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I would put 10 here. And the idea here is that, it's based on how the neural network is trained, it is going to highlight or light up one of those output nodes, those output neurons. So I'm basically using TensorFlow.js, writing code to design a model like this. Not the same concept, because this is doing image classification, and I'm not even doing classification, I'm doing regression, but I have the same idea. I have this sequential network. It's usually visualized or drawn in diagrams from left to right. This is being drawn from bottom to top. So the data flows this way in the sequence. Input data, that's there. Hidden layer, output layer. So that's exactly what I'm going to do. So I'm so glad that this course in Brilliant just perfectly illustrated exactly what I'm coding today. So thank you, Brilliant, for being a sponsor of Coding Train, a very, very dedicated sponsor. And what I'm going to do now is just take a short, like hopefully less than 5-minute break. If you have nothing to do during this 5-minute break, you're welcome to go ahead and sign up at brilliant.org/codingtrain. But I will be right back. I'm going to continue writing this code to try to finish this project. If I can get back in 4 minutes, I'll have 45 minutes to finish this project. So please take a break yourself if you can. Stretch, get some fresh air, meditate, practice some self-care, please. I'm gonna go get like a granola bar or something, give me a little energy for the next 45 minutes, and then I will be right back to finish this particular project. All right, so see you. I'm gonna put up the intermission animation right now, and I will be right back. I'm muting my microphone. Okay. Whew. I'm back. Woo, that was a good break. All right, how's everybody doing? I got a lot of flights of stairs to go down from the attic to get something. Woo. Okay, I'm back. We're gonna make this happen, people. How's everybody doing? Okay. Oh, nice. Some people are saying nice things in the chat. Mwah. That is very kind of you. I very much appreciate it. Okay, so we have now added. Oh, we're just gonna do one layer. So, and I want to change this back to 2. So I have a sequential neural network. Well, okay, if you just are tuning in, I'm trying to write a neural network to make mouse movement predictions. So I have a training data set of me moving my mouse pointer around in circles. And eventually I would like to use different data. And I'm now going to see if I feed that into a neural network using tensorflow.js, if I can get it to make the prediction to move the mouse around in circles. Okay. And I had a little piece of toast with a little peanut butter on it, in case you were wondering. I feel so much better. I could just like survive for the rest of my life with just peanut butter. just putting that out there. Okay. And some water. I had some water. I wanted to make a coffee, but it's kind of late and I didn't really have time. That would take too much time to make a coffee. I didn't have that much time to 5-minute break. All right. So what's next? Let's go back to the tf.js. And thanks again to Brilliant, the sponsor. Let's go back to the tf.js page. So the next thing I need to do is usually I have to like compile the model or something, or add some kind of loss function, optimizer, thingamabobber. I mean, I wonder if it has like a default of all that stuff. TF sequential. Usually like, oh, maybe that's all under model. Compile. Yeah. How come there's not an example of using compile? I mean, I could just go to my examples. So by the way, let's do this. I made a bunch of examples a bunch of years ago. Let's see, examples, P5 or something. Well, these are my videos. This is what I'm looking for. So this is from, well, I guess I made a change on 2019, but these are a bunch of examples I did. Let's look at this color classifier, which is probably relatively similar. What did I do? Right. So I did this a little bit differently. That's interesting. I like how this is done. So I didn't put in the specific activations. I'll get to that. But this is what I need. All right, let me just copy this. Sorry, everybody. Let me just copy this in here for expediency. So, all right. So what am I doing here? And this is, I'm gonna change this stuff. So basically, this here is architecting the model. And that is saying that here are my layers. Just 2 layers. The first one that gets this input. And you might be asking like, well, why is there no input shape in this layer? I could put one, but the tensorflow.js, the model can figure out what the input is into the second layer because it's the output of the first layer, which is 32. But the first layer doesn't know what its inputs are because that's my data. So this is me defining like, oh, this is my data, then put 32 things in here. And I don't, so I could, if I wanted to, do something like this. I think it would be this, but unnecessary. Whoops. Okay. So many autofill. So now once you, and so let's just sort of see like once I've architected the model, I need to say model.compile. Basically, the TensorFlow.js is going to do the work behind the scenes to like set up all the data structures and memory and math stuff that it needs to do based on, it doesn't want to do that until it knows what all the layers are. So I'm just curious if it'll like compile in some default way or if it gives me an error. Whoops. Oh, and let me I don't need to print out the input anymore. So I've seen that it's right. Right, so this is what I expected. It's giving me an error. It cannot read property loss of undefined. So what is loss? And I think that by accident I'm like using some meme or something that I'm not aware of because I'm an old. Loss is the term to summarize the total error of a neural network as it is going through its training data. So it's looking at its training data and trying to make predictions that match the actual answers that are embedded into that training data. And if it got everything 100% right, its loss would be a nice big round 0. Of course, that never happens. And if it is a 0, it's probably overfitted, which is a term for like your model is so good at making predictions based on the actual training data that when it's deployed into the world with non-training data, it's not going to do very well. But so in order to define the loss function, well, I need something that defines it. So we can see here, I could add in, let's add that in, loss. Now it says categorical cross entropy here, which is just from my other example, that's a kind of loss function that is well suited for classification algorithms, which isn't really what I'm doing here. So I'm going to look for, I think it's just root mean square root mean squared. I've lost my sense again of where, let's see. So let's see, what are the let's see, categorical cross entropy. There's got to be, here we go. Mean squared error. This is what I think I want to try. So these are a bunch of different like metrics for measuring how the neural network is doing. I'm going to grab mean squared error. Let's try that. Now let's see what happens. All right, so it needs all the stuff. So it also needs a optimization function. So what does that mean? So the neural network is full of all of these weights. If I went back to the original, if I went back to that diagram from brilliant.org, from the Brilliant website, you would have seen all these little lines that connect the different layers. They all have weights. So I need to figure out, well, how am I optimizing the weights to get to the best set of weights that produce the lowest loss? And so SGD stands for something called stochastic gradient descent. That feels like a fine thing for me to use right now. Learning rate, and a lot of my other videos cover this stuff in more detail, is so if I have an error and I want to like twist a dial to adjust a weight to try to get that error lower, like how much do I twist that dial? Like, do I just make little tiny changes as I'm going, or really big ones? So let's create this learning rate and optimizer and put that in there. I actually don't think the metrics thing, I don't know what the I don't know what, if metrics is just for if I want to like get a report on how it's doing, or whether that's actually doing something. But let's keep it, because I don't know, it sounds like accuracy feels like an important thing. So basically I am doing this. Okay. Now, something that was in my previous example was activation functions. And I do need to get into what I want to use here, because I certainly don't want to use, close this tab. You can see here that there's something called sigmoid and something called softmax. So we'll talk about those. I think I'm going to need different activation functions. But once again, I just want to see if this will run without an error. Great, no error. Moving along. Next up, I need to have the, so these are actually, so this is often referred to as the X's. The X's being the inputs to a neural network. And so my training data set would usually have X's and Y's. So the inputs paired with the output. So in the sort of canonical cats versus dogs image classification, my X's would be a lot of images of cats and dogs, and my Y's would be all the correct labels that correspond to those images. Here, my raw output, or I'll just call it raw output, is the 11th XY. So after I go through this, the raw output should get next row is lines I plus j plus 1, and I should get an XY from that. I don't know what to call this. Like, I'll just call it, maybe if I call it next, that kind of makes sense. And then push that XY into the raw output. So these are the raw inputs, chunks of 10, and then the 11th that goes to 11 is the output. Although I think now this needs to be -1. So I should be able to also say Y's is a tensor raw output, and I should have rows comma 2. Right, let's print the Y's. Let's just look at this also. That's, oh, I don't have I plus j. It's not I plus j, and it's not I plus j plus 1, it's I plus chunks. So chunks is 10. Yeah. Great. So these are all the next positions. Oh, they have to be normalized. So they also have to be normalized. So they should be divided also by the width and the height. Great. So these are the output tensors. The reason why I'm doing that is because the next thing I need to do is call model.fit. So fit is really a function for, it means what it says, but you would think like, oh, next thing is train the model, model.train. And actually, if you look at ML5, no train. I'm contractually obligated to blow the train whistle. Train is the word that's used in ML5. But fit is really what's going on here, because basically I have this neural network and I have this training data set. And I want the neural network to fit. I want to fit that data. Fit the data inside the neural network. I want the neural network to learn from that training data set. So I want to fit it. Why is it fit? I can't get this to like make sense. It's like it's so embedded in my brain to think of like I'm fitting the data, like we're fitting the model to that data. That's what it is. So what goes in model.fit? Oh, I can see it here. I think it's just X's and Y's. We can look for compile, evaluate, predict, fit. So we can see here, and oh, wow, here's my answer. I could just do, I can do something much simpler like just this, by the way. That's interesting. So I want to say model.fit, the X's, the Y's, and the number of epochs. Okay, great. Let's see here. So I'm saying model.fit the X's and the Y's, and then I guess I give it an object, which I want to say like how many epochs. So an epoch, is it epochs or epoch? I'm just going to say 1 right now. An epoch is one time through all of the data. Batch size is also maybe important here, but I'm going to ignore that for right now. Batch size is how many chunks of data batches of data, I guess I'm saying chunks, but a batch is like a chunk. How many batches of data, or how big should a batch of data be before I start tuning the neural network? So if I have 1,000 data points, I might do batches of 100, and that would be 10 batches of 100. And so I want to use this is an asynchronous function. It takes a while to fit the model. So I'm going to put this in a function. I'll call it train. And I'm going to say this is, it's an async function. And I'm going to say await model.fit, and I will call train. So let's await, and I probably should use some callbacks and things like that, but let's see, what is it doing here? Let's just try, oh, there's a hist h. Oh, I get something out of it? Cool. I guess I get information about, how the model was trained, and then I can, oh, I see. Call that H. I'll just do what they're saying. What's I? Oh, it's like calling fit a bunch of times? That's interesting. Why would you call fit? So here's my question. Why would you call fit 5 times? Why not just have it be 15 epochs? That's confusing to me. Does anyone know the answer to that? I don't know. But I'm not going to worry about doing it 5 times. Let's just say, let's look at the total loss when it's done. All right, here we go, people. Well, that didn't go well. Error when checking target. Well, got array 1424, 2. Dense 2 to have 3 dimensions. Right, so my data is not formatted correctly. Did I do that by accident in chunks of 10 also? No. I mean, is it just, no. I mean, I kind of know how to get this to work with flattening the data. It resets the neural net. People are answering that question in an interesting way. But first I want to get this to work. So did it get through? Like, let me just take this layer out for a second. Well, that doesn't make any sense, actually. Shoot. Error when checking target. Expected dense 2 to have 3 dimensions. But so this is right. That's the array's shape. But it should have 3 dimension. What? No. Is it really like... is it this because the X and Y are just one number? That doesn't make any sense. Blank 10, 2. Blank 10. Where did the 10 come from? Put shape. Oh, this is the bane of my existence with doing this machine learning stuff. Run the debugger. There's a debugger? I have no idea how that works. I'm going to figure this out. Okay, got this. Blank 10. Why is that? Where's this 10 coming from? So I feel like I know a way to get this to work that I was trying to avoid. I guess the X, Y's being in pairs don't actually matter. So I'm going to do this differently. If you will all, I'm gonna do this different. I would love to figure out exactly what I did wrong here, but I have an idea of how to do this differently. Oh yeah, it's actually just this, which is silly, but preferred shape. Provided shape. Oh. Huh? Okay. All right, I give up. I'm going to do this a different way. One thing I want to figure out is if I have an array, and I say a push 3 comma 2, that's my array. Then a push 9 comma 10. Great. Okay. I need that for loop of x's and batches. Chunks is 10. 10 is the chunks. Okay, hold on. People are telling me something here that does sound reasonable. Oh. No. Batches of 10. The chat is being helpful to me, but it's a little bit too much for me to follow. So I think I'm going to do this a different way that I kind of have more confidence in working. The fact that I'm keeping the XYs together is kind of irrelevant. It doesn't really matter. I'm not doing like a convolution here so that I could just flatten the data. Like it makes much more sense for me to just have this be 20 things in it. And then have the raw output be just 2 things. So that this now is chunks times 2. Right? This is like basically just changing it to, instead of having it be arrays of arrays, it's just like a 3-dimensional tensor. It's just 2-dimensional, which I think is going to make more sense. And then this is just chunks times 2. And then this, oh, no. Hold on, let me look at the example. All right, let's see. This is what I'm thinking. Yeah, that worked. So I think me trying to do the keep all the XYs together in their own little arrays sent me off on a bit of a tangent that's kind of unnecessary here. I know that was probably confusing for those of you watching because I did it in. So basically, let me just explain what I did. So I had it originally as each data point was the following: X, Y. So this is the inputs were like this with 10 of these. But I think it's ultimately simpler for it just to be this. So instead of having like lots of little internal arrays with each X, Y, which could be useful in case I need to like do some operations where keeping them in pairs is really important, but I'm not doing that. So I think this is better. Now, the other thing I want to do is I want to I want to be able to see the loss over multiple epochs, probably. So I know that, and I'm running out of time here, so I want to look for these. I think I can pass in callbacks. So I'm just going to grab this, which is some code that I have from another example that I saw. And it goes in the fit function. And I think if I do this, so what's this on epoch end? I don't need on batch end. I'm just going to get rid of on batch end. So I have callbacks. in addition to epochs. Come on, you can do it. You can get this syntax right. Epochs, callbacks. That's on epoch end, callbacks. I'm trying to like organize this the way that it's, and I don't need this lost p HTML nonsense. Epochs 1, callbacks on epoch, there, on there, and then there we go. So I added a callback, and let's give it 10 epochs, and then how do I get what did I do in my example? Logs lost to fixed. So let's grab that. Oh, epoch logs. So let's do, let's print out the epoch plus logs loss to fixed. I don't need a plus, that's why I'm using this string literal. Epoch and then loss. So let's see what happens here. So interestingly, I am getting a loss of NaN. Whoops, I didn't mean to split the pane. I have pane, I didn't mean to split it. So, and whoa, everything got so wide all of a sudden. Okay. Now, I think what's missing from this is a couple things. One is thinking a little bit about this optimizer. So I'm not sure if I'm using a really so-called smart optimizer here. But more importantly, I think the thing that's really missing are what are the activation functions. So I don't know what they are by default, but I am going to put in to both of these the sigmoid activation function. All right, given that I have about 15 minutes left in today's live stream, it's unlikely I'm going to really dive too deeply into what is an activation function. Definitely somewhere in one of my video tutorials I cover it. But if you were to think back to that, do I still have it open? The brilliant neural network library, but let's see if I can find one that would sort of make sense in this context. So I just want a, here we go, perfect. So this is basically a pretty, this is a 2-layer network. So there's how many inputs? I have 20 inputs because I have 10 XY pairs. My hidden layer has 32 and my output layer has 2, not 1. So that's the only thing that's different. But basically as the data flows through this sequence, it has to be processed. It's a weighted sum. So the input values are multiplied by the weights of the connections and then are passed through what's called an activation function. The activation function does a lot of, serves a few different purposes, but in this case, what I'm really thinking of is it takes the weighted sums and squashes them. And so one of the things that is important to me here is that I want outputs of the neural network that are between 0 and 1, so I can expand those easily back to 1920 by 1080. So, I really do want the output layer to be sigmoid. There is something that's sort of more modern, more sort of like currently used, which is called ReLU, rectified linear unit, which just chops up the negative values. I have no negative values though. I wonder if I should be mapping my data based off of like 0, 0 in the center. So this is really what I'm not sure. And this is also why using the vector between the next point and the previous point might make more sense. I don't really know. But let's just try it. Like, let's just live in like, the 1990s. I'm really looking a very basic, like, kind of classic neural network architecture with just like the classic sigmoid activation function with stochastic gradient descent. I'm going to lower this learning rate to something much lower and let's see what happens. Oh yeah, look at that. My loss What, by the way, is this? Is just some like auto printout something? Like, do I not need to do this in Node? Like, maybe I don't need this callback at all. I went all that time to do that callback because Node is going to automatically print out stuff for me. Well, that was silly. So I'm going to take that out of my code. And I could, well, that's fine. Let's give it like 20 epochs. Whoops, no, I don't need to do that. Okay. It's going down. I kind of like that. I mean, is it still going down? Let's give it 100 epochs. Down, down, down it goes. Huh. This is working surprisingly well. Why is this loss? Are these like the internal batches or something? Why do I have this nice, beautiful loss that's going down and then this loss that's higher? Regardless, I think now I can try to make some predictions. I'm going to make a function called go. And I'm going to say await train. Now I'm going to say, I'm going to make a function called predict. Oops. And basically what I want to do, let's take any arbitrary, what do I have? Is it raw input? I want to take any arbitrary sequence of 10 from my actual raw input. So let's pick, let's say I'm going to take a random number, math.random times raw input dot length, math.floor that, and then and it should be actually times raw input dot length minus chunks. Is that right? Or chunks? Oh, I could just take one of them. I already have it. Okay, great. Sorry. Raw input dot length. Now I'm going to say my inputs. My input is raw input dot index r, and then the x's are tf tensor inputs, and I should put that in an array, I think. And the shape is chunks times 2, just one of them, right? Because a 1 comma chunks times 2. I'm just going to predict one thing. I'm trying to just test, right? And then I can say the outputs are model.predict. So passing, now I'm using just some of the training data, which I realize I should create my own data. Like I should move the mouse and then have it continue. I won't get to that probably today, but I will get to that at some point. I want to get those outputs, and let's just see if I get something. So we're going to say await train, await predict. Say training complete. Making a prediction. All right, let's see. Await train. Oh, this has to be an async function also now. I need to call go. All right, let's see what happens. Okay, it's training the model. Loss is going down. And then, hey, I got a prediction. Now that's a little bit disheartening that the prediction is like be in the middle. Like I feel like that's not very good. Like maybe that's what it actually should be, but that seems. Let's do a bunch of different predictions. And what I should also do is I should actually pull it out of the tensor. So you can call the .data function, and then I can just console log the xy. Because in theory, what I could do now is just tell the mouse to go to these locations. Training. Let's see what I get. Do I get all? Yeah, see, I don't know. I mean, was my mouse moving around the center, and does that seem reasonable? So hard to know. I suppose I could quickly spin up the next step. I mean, I think for this to feel at all satisfying, I should. So, right, because we're not really seeing if this works at all. So let's go to the next step. And I'm gonna in order to be a bit more expedient here, I'm gonna go to the code from my talk repository and just grab like what I did here, which is to add a quick server. Although I guess I could use. Wait a second. Let me go back through the Discord. I can control the mouse with where was that? Dusk, I saw print gave me the link, but I can't find it now. Oh, I'm sure I can Google it. npm robot.js. Let's try doing this without processing. So this will be new. So there's a node package for desktop automation, just like in Java. It's called the robot class. It's called robot.js. So let's try adding that. And we're going to start moving the mouse. It'll be fun. You know, depending on what your idea of fun is. Definitely for me, this is my idea of fun. Okay. So actually what I need to do that's different is back into the code. Before I can do that, this was a very silly thing that I did, which was just like, oh, let me predict this a bunch of times. So what I really want to do is, here we go. I want to start with some inputs. So I'm going to start with an arbitrary set of inputs. And then I will call something called predict, my own function called predict, based off of those inputs. And I'm going to get hopefully a next point there. So predict based off those inputs, get the x's, get the outputs, get it as an xy, but return that. Then, and I want to do this. Then I want to say, let's just do it like 10 more times. I want to take the, I'm going to call slice just to make a copy of it. Slice makes a copy of it, right? Because then what I want to do is I want to say inputs dot splice the first two elements. Like I want to take the first two off, and then inputs dot push the prediction it just got, and then this should be let maybe, and then next is predicted again, right? Won't this do a nice little loop where I start with 10 mouse points, I predict the next point. Once I've got the next point, I take out the two oldest points, put it in, and then get a new next point and do that 10 times. Won't that work? And this should be await, and this should be await. Pretty sure that's right. It's a little silly that I have to, train the model each time, but I'm not, it's so fast because it's so little data that I'm not going to worry about that. Okay. Oh, how come it didn't do any prediction? Did I not console log anything? Oh, I'm not console logging anything. So let me hold on. Where was that? Where am I doing prediction? I've lost it. Sorry for all the scrolling. I'm getting a little tired again. Oh, this is where I call predict, but I want to do it here next. So maybe this is probably like, let's just do this. A little silly, but I'm just gonna log it here and then log it here. Okay. And let's lower the number of epochs just to get to see that it's working. Yeah, look at that. So those are the 10 next mouse positions to move to. So now, in theory, where's this robot.js thing? I was there, robot.js. Let's go to GitHub and see. Okay. Robot equals require robot.js. Now, key tap, mouse, get mouse position. I want to move the mouse. Robot move mouse. Is it really that easy? What does set mouse delay do? Well, so now, is it really as... So let's say move mouse next. Oh, no. I want my own function. No, wow, it really wants to type out what I want to do. And then I'm going to write function move mouse. This is very bad. It's going to take over my mouse. And then point, comma 0 times 1920. Point, comma 1 times 1080. Okay, everybody, are you ready to watch my mouse get the AI take control of my mouse? It's just going to do it for 10 points. Let's throw caution to the wind and give it 100. Is my mouse moving? Oh wait, what? What happened there? It didn't print out the predictions. Well, I took out the predictions because do I need like a callback for moving the mouse or a mouse delay? It probably did it so fast. I guess I need that mouse delay. That's speeding it up? No. Okay, hold on. No, it's doing it just like, does this work? Let's just try this for a second. Weird. Okay. Did it do it? Let's console log. Let's console log what we're putting in here. Well, let me check the chat here. Oh, that's where it was supposed to go. I don't think it's working very well. This is what I didn't think would work. Set mouse delay 100. Make sure you're focused on the terminal. Okay. So I need to set mouse delay. Let's try that. Robot set mouse delay 100. And let's let it train the model a little bit longer and see. I don't even know where the mouse is. I don't see the mouse. Does anybody see where it is? I can't find it. 958 should be like, is this where it was? Okay. Let me put it over here. I'm going to put the mouse over here. Everybody see it over there? Here's where it is, right? It's over here between these leaves. But clearly this is not working because it's just stuck in one place. So this is my problem. Wait, where'd the mouse go? It already moved. Where did it go? This is the end of our today's live stream. I'm actually just really curious to try this example with the sine wave. This is really, but where does it getting? Oh, okay. I'm just curious to try this. Let's just try this. Mouse. I'm just going to create something called mouse.js. So this, I just want to see this. I just want to watch to see if this moving it in a sine wave works. Let's try this example. Where is the mouse? Am I just blind? Okay, I'm starting it over there. Do you see it? It's over there. I'm keeping my eyes glued to the mouse. Okay? I'm looking straight at it. Oh wait. I'm looking straight at it. As soon as I do that, it's gone. And I can't find it. Interestingly, and I'm able to move it myself. What am I missing? I'm looking in the chat to see if anybody's telling me. Could be going behind the window. Could be going behind the window. That's interesting. Let me see. I should read the documentation a little bit better. I mean, that's what I should see. If you need to build, no, gonna be in here. Xcode. I mean, I have all this. Huh. Pull up a blank white screen. That's not a bad idea. Look who has a nice blank white screen. Why also is it just stopped? Do I have my cursor set to hide when I type? Oh yeah. My cursor is set to hide when I type. So where is that? Is that a that's weird. Where is that setting? Okay. Why does my cursor disappear? Control panel, mouse properties, pointer options. Okay. I have to go soon, people. There's a conference happening. I got to get set up for that. But I just want to see this work. Let me make sure nobody's sending me any crucial, like, emergency messages. Okay, not that I see. All right. Where was that? Mouse? Mouse properties? No. Control panel, mouse properties. Is this not on the Mac? Well, this is like from 2013. Quickly shake your mouse. That doesn't seem like the right stop. Is it a iTerm setting? Yeah, wait, hold on. Yeah, it's only an iTerm. It's an iTerm setting. Pointer. Ah! Click. What? Focus follows mouse. That's weird. Nobody knows, huh? Why? think I spelled disappears wrong. Use VS Code in build terminal. Wiggle it as soon as I run the script. Yeah, but the whole point is... Ah, wait, I think I got it. Except it's not moving. First of all, why is it taking so long? Oh, because I have the delay to 100. Oh, I don't want to set a breakpoint. Like, it shouldn't let me move the mouse. All right, hold on. This must be an OS X thing. Well, all right. I should just go back to processing. Processing definitely works. I should have been there. So this is I got sidetracked to trying to do this in Node. All right, don't worry, everybody. It's okay. Just give me a second here. I'm gonna not worry about trying to do this in Node anymore. All right. So this is great. So I'm gonna go back to. Somebody can help me figure that out, but let me go back to my actual. What I did. Where is this one? No. Predict mouse movements. Okay. So what I did when I was trying this is I just can quickly add a node server. I'm just gonna get all of this from the bottom. So I'm gonna grab this, and I'm gonna go back to here. Let's take out this mouse move. And I am going to, so I'm going to say npm install express. So now what I'm doing is I'm creating a little server. Oh, and I made random inputs, which, oh, that's interesting. I did this in a different way eventually, I think. But, sorry, I'm just thinking about this. Mouse. So that's fine. I'm going to start with something random. Then I'm going to call await. This is the same thing. Oh, this is, and then send those back. So this is basically from processing. I can just ask for the next 2 points. Let's see if this works. So now I'm going to go into processing, create a new sketch. I am going to import the HTTP request, not PZCam. Import the HTTP request for processing. And again, because I'm kind of out of time here, I am going to really just grab this mouse. You know what? I'm just going to grab this completely. So basically, oh, but I was doing something more here. Was I? I'm not sure. Let me just grab this. I don't know what this is doing. Oh yeah. Oh, because I was working with vectors at this point. All right, I'm gonna make this much simpler. Okay, so mouse mover. So, and then import the library. I just want to have a little win here before the end. Okay, so I am going to the other thing I need is I need to get the content back and console log it. Okay. And print line move to. So basically what I'm doing here now is in my server, instead of actually calling predict here, I'm just going to train the model. And then whenever processing sends a GET request to the server, it will run the prediction and send the XY back to processing. So let's try this. Let me just think, no. Oh, I'm not running the server. That would help to run the server. Oh, not that. We're almost there, folks. Land this plane. No, what happened? Snapshot is not defined. Index.js line 99. Oh, snapshot is like chunks. Chunks times 2. Ooh. Right, because I need 20 numbers. I think that's right. Okay, we're training the model. Once the model is trained, I love how I really thought I was going to get to like trying to use a recurrent cell. Once the model is trained, I'm going to hit run. Okay, great. Look at this. I got it back. I got the XY back. Beautiful. So then now I just need, will it, oh, it's already doing the splicing. So it'll give me the next one. So now I can just say void draw avoid setup. Okay, right now I'm getting mouse positions. Again, this is going to be very sad because it's obviously clearly not going anywhere of note. But let's at least get it to work. So all I need now is the robot. We are the robots. Import, I think it's from java.awt. And I need to say robot. So I've got the robot. And now the only function I really need is called robot mouse move. And I will say the values are convert move to splitting up by a comma to floats, and then mouse move to values index 0 times 1920 and values index 1 by 1080. What's wrong here? It needs double quotes. Let's just make sure this actually works. And yeah, right. I don't. It's keeping it in the center. Oh, so sad. Let's make this look a little bit more interesting. I should do the sine wave, but and I'm going to do something terrible, but I can't resist. So instead of using the neural network, let me just pick some random values. Oh, that's P5 code. Just so I can see the mouse actually move. And then I will upload this code and maybe somebody can help me develop the model architecture in a way that it actually does something. I should have also started with actual mouse points that are going in a circle, but I have to wrap this up. Let's just give it one epoch. Okay, here we go, everybody. Yay, the mouse is moving randomly. You can see it. I have a better idea. Oh, no. I got to stop. So you get the idea. I'm looking at the chat just for a second. All right. So we have all the pieces working, right? I have, just to recap for a second, is I'm going to post all this code, and I would welcome any contributions. I didn't get to actually implementing the recurrent neural network. I think there's just like probably a lot of fundamental flaws in exactly the way that I'm doing this, in the sense that I just don't even know if it's really reasonable to expect that 10 XY positions could predict a next one. I don't know. It doesn't sound so crazy to me. So I think it's really the model architecture, but let's just recap. So I have a training data set of XY positions. I have node code that, and I'm going to take this out. We don't need this anymore. That loads that data set, puts it into tensors, it's ready for a neural network. Then I take it in groups of 10. So 20 values, 10 XY pairs with the next position. So the X's are all those 20 values, and the Y's, the output of the neural network, is just 2 values, the XY prediction. I set up, maybe I should have tried just like a different activation function, who knows? But I set up one layer with 30, I never even bothered to explore like how many hidden layers. One output layer. I never explored different activation functions. I never explored different optimizers, different loss functions. So all these things are things you could explore. Then this is no longer relevant. Then I'm training the model. Then after I train the model, when it's done, there is a node server that can just receive a message like at a particular route, and then it's going to, well, I should put this back, call predict on the model, kind of, the input, this is a flaw here. I just made random numbers for the input data. That's probably a big problem. So this is something that could use, so let me actually put some notes in here. How to start the input. Pull from training data. Here's something else. Should I try more or fewer points? Is this model architecture reasonable? Try a different activation function. So this is something you could explore. All these things are things. What optimizer and loss function. So that all, and this is all otherwise quite reasonable. Training it, calling predict, having processing call predict. And then this also is totally, there's nothing to this code. It's just like, hey, once a second, query for a mouse position and move the mouse. So I'm going to very, very quickly, the last act of this live stream. Oh, I forgot to scale it up when I used robot.js. Was that the problem is? I don't know. Still the mouse was disappearing. Who knows? Okay. I might have forgotten to scale it up when I was using robot.js. I think I did. Anyway, too late. Let me very quickly make a GitHub repo. Honestly, this is mostly what's in that other repo. But let me put it in the coding train and just call this mouse live stream April 30th. Let's make this public and add a README. Let's add a file. I definitely need to do a .git ignore because then I want to say node modules. I don't want any of the node modules. Okay, so commit that. And then now this is like a crazy way to commit a project, but it'll do. I don't want this. So let me add this up here. There we go. So here's that code. And then the processing sketch, I guess, is unnecessary if the robot.js in Node worked. But let's put this in here. But now you have all the code. I can go to the Coding Train Discord. Shout out to the Coding Train Discord. Posting the link into the chat. While I live stream, there's a channel here called Schedule where I will, if things are going well, post announcements about when the next live stream will be. And then links is where I will share things that I'm doing. Like, for example, now that repo is there. And then also, I think probably for reference, why don't I share this link as well? All right, that I know this is like a kind of a rush to get out of here, but this is the end of today's live stream. Just peeking at the chat. Yeah, so something that I was interested in trying is there's something called deep SVG. So if I could convert all my mouse movements into SVG, then I could potentially use this to predict the next mouse movement. So that I would love to explore. The next step that I wanted to explore that I never got to is if I go to tensorflow.js and look for API tensorflow.js. This is what recurrent neural network. Yeah. So this in theory is what I really should be using from the start, but I don't feel confident enough in my TensorFlow.js knowledge that I wanted to try this method first. But this is my next step. If anybody wants to take this project and experiment with doing it with tf.layers.rnn, please be in touch with me. I probably should have collected a lot more data. There's so much that's missing. I would love to solve this. I've got to move on from this mouse conference video and examples, but would love to circle back to it at some point. So please, any suggestions, at Schiffman on Twitter, leave a comment in this video's description. As soon as I turn off the live stream, comments will be available. And I'll see you next. I think I'll be back next Friday. I should be back next Friday. I'm going to be having fairly regular, at least 2 or 3 live streams in May. I have such a backlog of tutorial videos to get out. Oh my goodness. At least 8 or 9 of them. And then stay tuned for the actual mouse conference video, which will be out on the channel early next week. I hope that you enjoy it. And that's all I have to say. Thank you, everybody. I'm sorry that I'm not haven't shared community contributions in a while. I haven't released a coding challenge in a while. It's the circle of coding train life. We'll get back to it at some point. All right. Well, we close. Let's see. How many tweets of my mouse movements have gone up? It's pretty interesting to see these. All right, these are all the mouse movements from my live stream today. Probably should not be doing. I gotta go into the server and give it a more. I guess allow a larger image. All right, this is it. I'll see you all. Oh, stop! Hold the presses. Hold the presses. I'm going to be back in 35 minutes. I forgot. I completely forgot. Guess what's upcoming live stream? So if you missed yesterday's live stream, Neto Bomani is during the mouse conference. We got the audio of the mouse conference available for you to listen to. There's a lot of panels tonight, so even just listening to the audio will be great. And you can watch Netta live create a zine in this stream. I'll be there in the chat moderating. So if you have questions about this mouse code stuff, I'll chat with you during that. And it's just beautiful. The work that she's doing is amazing. We are also fundraising. I meant to mention this for, oh shoot, I'm logged in. Just give me a second here. Let me pull this up. Oh, no. It's in the description. So, here we go. I just want to mention a shout out. Thank you to Brilliant, by the way, for being the sponsor. Oh, wrong button. The sponsor. I am donating a portion of the sponsorship fee today to Survived and Punished. They have a goal of reaching 100,000. I reached their goal. Amazing. Well, I'm still going to donate. 2 days left, but that's wonderful to see that Survived and Punished reached their goal of. It's a mutual aid group project of that exists to end the criminalization of survivors and of domestic and sexual violence. A wonderful organization that Netta introduced me to. So if you're able to donate, I highly would encourage you to do so. So that is really all I have for today. Come back for the live stream in about 35 minutes. It won't be me coding, but I think you'll really enjoy it and hang out in the chat. All right, everybody. See you then. As always, I always forget the this dot, this dot, this dot, this dot. I'm going to do this dot, this dot. I'm going to do this dot, this dot, this dot. I'm going to do this dot, this dot. I'm going to do dot, this dot, this dot, this dot, this dot, son. This dot, this dot, this dot. Never forget this dot, this dot, this dot, this dot, this dot, son. This dot, this dot, this dot. Never forget this dot, this dot, this dot, this dot. I'm going to do this dot, this dot. I'm going to do this dot, this dot, this dot. I'm going to do this dot, this dot. I'm going to do dot, this dot, this dot, this dot. I'm going to do this dot, this dot. I'm going to do this dot, this dot, this dot. I'm going to do this dot, this dot. I'm going to do this dot, this dot, this dot, this dot, son. This dot, this dot, this dot. Never forget this dot. This dot, this dot, this dot. Never forget this dot. I'm going to do this dot, this dot, this dot, this dot, this dot. All right. Never forget. Goodbye, everybody. Usually I play a few more songs, but I got to run and get set up for the next stream. So see you then.